let's compute a sample double polar integral here. So I'm given a function, f of xy equals x plus y. And what I'm trying to integrate is on this region. The value, region R where x, all the points x, y, where x squared plus y squared is less than 36, x is positive or 0, and y is greater than or equal to 0 as well. So if x and y are both greater than or equal to 0, that puts you in that first quadrant. And x squared plus y squared less than or equal to 36. Well, if this was just equal to 36, that would be a circle of radius 6. But all the values that are less than or equal to 36 is the shaded in disk. So we have this. Now, this is a terrible circle. This definitely looks more like a parabola than a circle, but it's about my fourth try at it. So, what are you going to do? All right, so what this tells me is I need to, if I want to do a polar integral. Now, I could do this integral the standard way. In fact, for this particular one, I might consider doing it the standard way, but let's use it as an example to do a polar integral. So, let me get some better colors here. What I want to do is I need to define what my limits on R and what my limits on theta are. So, if I'm looking at this particular case, then I know that R, that's purple. Let me not do purple. I know that R goes from 0 to 6, right? It goes from 0 to 6. And I know that theta goes from 0 to pi over 2. Because I'm winding upwards. And you might ask yourself, well, why doesn't it go from pi over 2 to 0? And the simple case is kind of like a right-hand rule situation where you're curling so that you're coming upwards. So we usually define counterclockwise as the positive direction. All right, so let's compute this thing. Now remember that the way we want to do this is we say that instead of the double integral on the region, we can get an iterated integral where we have the R value 0 to 6 and the theta value 0 to pi over 2. And then we plug in cosine theta and sine theta into the function. So I wrote r d theta here. So if I'm going to do r d theta, I need to actually swap my limits of integration. I believe in this particular case, what you'll find is that it's probably perfectly fine to do r d theta dr, just swap them. But for the sake of the standard form, let's just follow it. So what we have is 0 to pi over 2, 0 to 2. So anywhere I see x, I plug in r cosine theta. And anywhere I see y, I plug in r sine theta. And then I have this r multiplied by everything, so that's actually r squared on both. dr d theta. So if I take the antiderivative here, again, the thetas are constant since we're integrating in r. So I get, and then the r squared can be factored out of both of these. So I get 1/3 r cubed cosine theta plus sine theta from 0 to 2 d theta. Well, when I plug in 2 to this, I get 8/3, and then 0 pulls out. So I end up with 8/3 0 to pi over 2 cosine theta plus sine theta d theta. So I get 8/3 negative sine theta, sine theta minus cosine theta from 0 to pi over 2. which is 8/3. Pi over 2, that's 1. Pi over 2, that's 0. So 1 minus 0, negative 1, because cosine of 0 is 1. So that added together is 2. 16/3. Made a huge mistake here. Notice I went from 0 to 2. This is all 6s. So over here I get r cubed. Well, 6 cubed is 216. 216 divided by 3 is 72. $72. 144. This is why it's good to make notes, check your notes, because you could easily be doing something stupid and you need past you to tell you that you are doing something stupid so that present you doesn't make a mistake in front of a camera.